Okay, so this example, I'm going to take a question that we looked at previously and show you how to just do something else that sometimes you're asked to do in an exam. So we know that this suitcase is in equilibrium. The forces acting on it must be causing it to be stationary. It's in equilibrium. And we know that there's a downward force of weight acting, which is 164 newtons. We worked that out previously. We know that there's a 50 Newton upward force acting on the handle. Now, sometimes you'll be asked in a question to work out what force is being applied at the pivot. Well, we know that at the pivot point, there must be an upward force acting on this suitcase, okay? An upward force F acting on this suitcase. And because this suitcase is stationary, because it's all in equilibrium, we know that the sum of the forces acting on this suitcase must be zero, okay? So there must be zero resultant force. And therefore, we know that the downward force of 164 newtons must be equal to the total upward force, okay? And therefore, this force F here must be equal to 164 take away 50, which is going to give you 114 newtons, okay? Now, how can I be sure that's right? Well, we can look at it again with moments. So if we take this now as our pivot point, rather than this as our pivot point, so we're going to say that this suitcase is pivoting around the handle, okay, around where the person is holding the handle. So we don't worry about this force because this is no perpendicular distance from the pivot, but we've got two forces then acting at a perpendicular distance from the pivot. We've got the weight acting clockwise around that pivot point, and we've got the force upwards from the ground pushing it up on the on the suitcase. That is providing an anti-clockwise moment, okay? So we know, because everything's in equilibrium, that the sum of the clockwise moments must be equal to the sum of the anti-clockwise moments. So clockwise, we've got the weight, which is 164, multiplied by its perpendicular distance from the pivot, which is 0.32 meters. That's the perpendicular distance from the pivot. And then we've got anti-clockwise, we've got this force F, which we don't know. Well, we do know, but we're going to try and find it out a different way. So we're pretending we don't know it at the moment. Multiplied by its perpendicular distance from the pivot point, which is 0.46. So F is going to be equal to 164 times 0.32 divided by 0.46. And that's going to give us an answer of 114 newtons, which is exactly the same as what we had previously. So we've proved by two different methods now that this upward force at the wheels is 114 newtons.